in today's lesson, we'll be finishing off our knowledge on time payments or loan repayment questions. So we're starting off with question 5 here on page 61. Jet buys some furniture costing $12,000 from a department store using the repayment plan. They charge no deposit and no interest for the first 15 months, which I think is very important, so I'm going to highlight that. Although the first repayment is due at the end of the first month. I'm going to highlight that as well. Okay, after 15 months, the interest rate is 0.9% per month. Okay, let's highlight that. And Jet repays the loan over 4 years with equal monthly installments of $M. So we know that eventually it's going to be 4 times 12, which is 48. Great. Now, what sets this question apart from other questions is this part. Okay, I don't like the way I highlighted that, so I'm just going to change that, sorry. So over here, they charge no deposit and no interest for the first 15 months. The question is asking, find an expression for the amount Jet owes after 1 year, so the first 12 months basically. So if I do A1, that simply means that I've borrowed $12,000, or Jet's borrowed that, and there is no interest applied for the first 15 months. So we're not going to multiply by that, 1 point blah, 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 blah. We're not going to do that at all. We're just going to go straight to subtracting a repayment, because at the end of this month, he pays off an installment of $M, which we don't want to know what that is. So A2 would be this amount subtracted by another monthly repayment. So that's just going to be 12,000. Sorry, I just wrote too many zeros there. 12,000 minus 2M. And A3 will be 12,000 minus 3M, and so on. So if I then use this pattern to generate what A12 is, so the amount owed after 12 months, that will be 12,000 minus 12M. So this person started owing this much, but now he owes less because he's made 12 of those repayments, and no interest has been applied, which is great. Okay, now for question B, show that the amount owing after 18 months is given by this expression. Now, how long can I actually do this for without paying interest? That would be 15 months. So we're going to do A15 equal to 12,000 minus 15M, but A16 is the first month where interest is applied. So I'm going to copy down what A15 is, right? And what I'm going to do that is that interest is now applied. So I'll multiply by 1.009 as indicated by this interest rate. Then I'll have to subtract a repayment at the end of that month and expand. So by expanding, I will get 12,000 minus 1.009 minus 15M times 1.009 subtracted by another M. Then A17 would be A16. So I'm just going to copy that down. And I will repeat the same thing again. So I will multiply by 1.009 minus M. So that will be now 12,000 times 1.009 squared minus 15M times 1.009 squared and minus 1.009M, and then finalize that by writing the minus M at the end. A18 would equal to A17's amount. So again, I'll copy this down here. And I will multiply this by 1.009M, 9 minus M. And by the way, there's just a bit of space on the next page, so don't cram everything here. I'm going to expand that. So this 1.009 will end up being cubed. Next one will be also cubed. 1.009 squared M minus 1.009M, then minus M. Now we've got to make it look like this. So we've got the beginning already, okay, I think. So they have just factorized out 1.009 cubed, which is over here. So if we factorize that out of these two expressions, we shall get A18 equal to 12,000 minus 15m times by 1.009 cubed minus n. So we'll factorize out a negative m at the end, going this way. We shall get 1 plus 1.009 plus 1.009 squared. Okay? And we've proved that statement. All right, question C. Find the value of m. Okay, so we need to find out the value of m by firstly finding out when is it that they owe nothing. So in this question, if you get rid of it, Jet repays a loan over 4 years. So I established before that 4 years means the same thing as 48 months. So we're going to try and find A48. So just by using this pattern here, A48 would equal to the same thing as 12,000 minus 15m. Okay, notice how there's nothing here related to that number, so we don't worry about that. So we just copy that down. But over here, remember that from the 16th month to the 18th month, this amount has been applied with 3 months worth of interest. But what goes over here then? Well, the difference between this number and this number is basically 15. So we subtract 15 to this, we do get that 3. So if we subtract 15 to this, that'll give the power there. So that'll be power of 33. All right. Then we minus m, and we copy down the rest of that geometric series. But the last term here will be 1.009, but it's going to be raised to the power of 32. And the reason being is because 18 minus 16 gives you 2. So 48 minus 16 gives you 32. Then we know that A48 is going to give you 0. They are nothing at the end of 48 months. So 0 would equal to this whole thing. But what I'm going to do also is, if this is 0, I'm just going to write that this is 0, then I'm going to skip a step and move all of this stuff here to the other side, and also apply the sum formula to this series. So that will be 1 bracket 1.009. Now this would have 33 terms because this number 1 here is 1.009 to power of 0. So getting 32 minus 0 plus 1 means that there's 33 terms. So we'll have 33 as a power, since it's 33 terms. And then we're going to write minus 1 here over the ratio 1.009 minus 1, and that's equal to 12,000 minus 15n times this. But at the same time, what I'm going to do is I'm going to expand this. So I'll get 12,000 times 1.009 to the power 33 minus 15m times 1.009 to the power 33. So just remember that in our question, we're trying to aim for the letter m. And the letter m appears here and here. So I'm going to grab this and put it to the other side. But just whilst I'm doing that, I'm going to skip a step. If I factorize m out of this, right, I will get 1.009 to the power 33 minus 1 over 0.009. But if I bring this over and I factorize that m out, okay, I'll get a positive since I've moved the negative term over. And I write 15 times 1.009 to the power 33. And this should equal to 12,000 times 1.009 to the power 33, right? And what I'm going to do is divide this whole thing over. Okay, so I'm not going to write that down, but that divided by all of this should give us $276.23.7, which is basically roughly around $276.24. Okay, so that's the monthly repayment that this person has to pay for 48 months in total in order to pay this off. Right, let's do our last question. Question 6. Alison decides to invest an amount P dollars into an account that earns 2% interest compounded quarterly. Okay, this question is compounded quarterly compared to monthly that we've done before. At the end of each year, she intends to withdraw a certain amount, W dollars, to pay for her annual holiday. Show that if Y10 is the amount in the account at the end of 10 years, then this is equal to this expression. So instead of the A value that we always used before, we're going to now use the Y. So let's see what Y1 means. Y10 means after 10 years, so Y1 means after 1 year. So what happens after 1 year? We start off with the amount P dollars, which is right there. We don't know what that is. And we're going to multiply it by this rate, which is 2% compounded quarterly. Now, I'm just going to stick to that, which is 1.02. But if you think about it, in a year's time, you're actually going to raise this P dollars by 2% every quarter of a year. So in 1 year, we're going to multiply this by 1.02 4 times. So that means this is the same thing as 1.02 to the power 4. Then at the end of this year, she intends to withdraw a certain amount W dollars. So we're going to subtract by W, right? Now Y2 would equal to what's owing in, oh no, it's not what's owing, it's what's invested in Y1, okay? Then we're going to multiply this by 1.02 to the power 4. This indicates that this amount is grown by 2% every single quarter for 4 quarters in a year. And we're going to subtract an amount at the end that she withdraws. So if I then expand it, I'll get P times 1.02, but the 4 and the 4 would add together to give us the power of 8 minus 1.02 to the power of 4 W minus W. Then let's go into Y3 just to get one more line for the pattern. We'll get Y2's amount. And what we'll do is we shall multiply that whole entire thing by 1.02 to the power 4 minus W. So this will now be 1.02 to the power of 12 minus 1.02 to the power of 8 W minus 1.02 to the power of 4 W minus W. Right. So we can now generate a pattern and factorize out the W at the end. So the first term of P times 1.02 to the power of 12, I can leave there. But I can factorize negative W from the end and factorize this way. So I will get 1 plus 1.02 to the power of 4 plus 1.02 to the power of 8, like that. And remember, my goal is to find out what Y10 is. So it's the amount in the account after 10 years. So if I then continue on this pattern, Y10 will be P times 1.02. Now what would actually be here as a power is 4 times of this, because every single year there's 4 quarters. And what goes over here is 1 plus 1.02 to the power of 4 plus 1.02 to the power of 8, plus so on. Now, the thing is, the last term here will be 36. Okay, let me explain to you why. So you can see that these powers here are generated as basically multiples of 4. So this is 1 times 4, this is 2 times 4. Now if it's y3, then if you have a look at the pattern, okay, this 2 here is 1 less than this, okay, and then multiply by 4. So if I then get 1 less than this number, which is the number 9, and times that by 4, I'll get that 36. All right? Now, what I'm going to do is I'm going to try and aim for this expression right here. Okay, let me just copy that down so you can see that. That's lagging. Here we go. So I'm trying to achieve that. Right, so I'll just keep writing the y10 since it's on the left side anyway. Then I'll have p times 1.02 to the power 40 minus w. And now let's sum this up. So our a value is 1, and the ratio here is 1.02 to the power 4. So we're going to do 1, square bracket, 1.02 raised, this is to the power 4 as a ratio, but it's raised to the power of 10 here, okay? There are 10 terms altogether from beginning to end, okay? So all you have to remember there is this term here is basically 1.02 to the power of 0. Let me just write that. 1.02 to the power of 0, whereas this is 36, but this can be written as really 9 times 4, whereas this one here is the same thing as 1.02 to the power of 0 times 4. Okay? So if you think about it, how many numbers are there from that 0 there to number 9? You just do 9 minus 0 plus 1, which is 10. And so there's 10 terms. I mean, otherwise you can count it one by one. Okay. Or you can just divide that number, 36, by 4. And that will give you 9. So there's 9 numbers there from the first multiple of 4, and then add another term there, which is going to be 10 terms. So it's up to you which other way you want to do it. Then when we simplify this, y10 will be exactly what this is. So we just have to multiply these two amounts. So we'll just write that down. Okay, so I've got the answer for the first question. Now for question B, it says if Alison withdraws $2,500 every year, which is simply the withdrawal or W amount, and the account will be empty at the end of 10 years, find P. So this means the account here, Y10, would equal to 0, right? So we've already got y10, which is this. So this is all equal to 0 at the end of 10 years. And this person's withdrawing $2,500 out. So let's just replace that by 2,500. So 0 would equal to P lots of 1.02 to the power 40 minus 2,500 times of this number. So all that it is for you to rearrange this formula to solve for P. So if I just move this over to the other side, I'm just going to cheat and copy that over. Whoops, wrong one. Here we go. So that should equal to P times 1.02 to the power 40. And once again, if I then if I then just divide this number over, just the 0.02 to the power 40, like that, I will get P would equal to this amount here, divided by 1.02 to the power 40, and that will get us P, which is the principal, okay? Or basically what amount this person put as an investment at the very beginning of the account. All right, so that will get us P equal to 16,592.722, ... So roughly speaking, the investment amount would have been 16,592 and 72 cents.